So here is some information on generics. Generics were introduced in Java 5. Uh, Before introduction of generics, there was no way for the compiler to know what is going to be in the collection. So there was no syntax which would specify that this collection will take objects of this particular class, and hence generics were introduced for this purpose. Also, before the introduction of generics, whenever we want to read any uh, particular object that is put into collection, then we would require typecasting that particular object to the object we want as a result. So like we see in the next line of code, list is of raw type, which does not have any particular uh, generic type specified. So we can put any object of any class in the list. So while reading the list at index 0, we require to typecast the value to string so that we can run all the string related functions on str. Also, the unboxing will not help here because list.get0 will return an object of type object, and unboxing will work only on the classes such as integer or double, which are basically the wrapper classes. So if we write something like this, int I is equal to list dot get 1, then we can't expect the uh, auto unboxing to work here because list.get1 will return an object, so we have to explicitly mention int here. So let's again reiterate, why are generics used? So generics are basically used so as to let compiler know what is the class of objects that we are passing in the collection, and why does this is helpful for compiler. This is helpful because during compilation it can check for the type safety. So generics are basically used for compile time type safety. And also we should know one thing about generics, that generics information does not exist at runtime. So no generics information is available at runtime. It's erased, which is also called as type erasure. So how are collections defined with generics? Let's take an example. So we can define something like list of string ls equal to new array list of string. So this is a valid definition for generic, but you can't define this way. This is a wrong definition. Like for example, list of number is equal to new array list of integer. So although integer might be a subclass of number, but this type of definition will lead to compile time error. But something like this is a valid definition. Say object array, or say my array equal to new integer say 10. So this is a valid definition. So why is this too different, and this is why is this allowed, uh, the third statement is allowed, and why not is second statement allowed? And this is because we have to know this, that polymorphism does not work same way for arrays and generics. So why can you do this? This is because there is a runtime exception called array store exception, which will check at runtime that the type, the object that you are putting in the array belongs to a wrong class. So this will be checked in case of arrays. So this particular exception will be thrown, and it's a runtime exception if you try to put wrong type in the array. So this is allowed by compiler. But in case of generics like this, there is no equivalent exception, there is no similar exception uh, to be thrown like in this case. So JVM knows the type of array but does not know the type of collection, and that is because type erasure occurs. So during compile time, by the time JVM gets to know uh, this particular type is erased, so it looks like a normal list, a raw list, and compiler does not know that this list is of type number. So there is no equivalent exception for generics because of this type erasure.